Hi, this is Seyed from EDD Academy, and today I'm going to be covering indefinite integration or antiderivatives from Unit 6 on integration. Alright, so first let's cover antiderivatives and indefinite integration. So we already know how to take derivatives and what the general process is. d dx of some function capital F of x is equal to f of x. Alright, very simple. However, what if we were looking for the function capital F instead of f of x? We would need something akin to an antiderivative, almost like an inverse function. Alright. So this seems like a pretty standard problem. So how do we go about doing it? Just like how an inverse function undoes a function, for example, f inverse of f will give you x, an antiderivative or indefinite integral undoes a derivative with a catch. There's a c at the end once you use the indefinite integral. So if you take the integral of f of x dx, which is equivalent to the integral of the derivative of f of x, of capital F of x dx, you'll end up with capital F of x, but you'll end up with a constant of integration, as it's called, at the very end. Okay, so you might notice that based on our previous videos, that this is called an indefinite integral, and the symbol is also the same as the definite integral. These two are very closely related, but that's for a different video. Now, why is the constant c at the end of the equation once you do the indefinite integral? Alright, so let's prove its existence. Take the derivative of capital F and call it f of x, like we did earlier. Alright, now take the derivative of capital F plus c, where c is a constant. So, you guys can probably see where this is going. So, the derivative of that sum, you can break it apart into two different derivatives. The derivative of a constant is 0, right? Because you get d dx of capital F plus d dx of c. So you end up with just d dx of f of x of capital F, which will give you f of x at the end. So for a given integral, right, there is then technically infinite amount of solutions because that constant, it'll just vary the graph vertically. Okay, and now here's a technique, a very basic integration technique. So the integral of x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1 plus the constant of integration c. Unless n is negative 1, because clearly that would be division by 0, where the derivative then becomes the integral of 1 over x dx is equal to the natural log of the absolute value of x plus the constant c. Both of these are pretty easy to verify since they're just the opposites of their derivative corresponding formulas. Now, something important I want to mention about integrals, they share many of the same properties as derivatives. For example, the integral of a sum is equal to the integral of the components of the sum. For example, integral of a plus b dx is equivalent to integral of a dx plus integral of b dx. It's pretty easy to see, but it'll become important for the problem. So here's some examples. Find the indefinite integral of the following. Y is equal to x squared plus 1. Now, this is pretty standard. Integrate and use the power rule. So first, we want to break it apart using that sum rule I said. Get the integral of x squared dx plus the integral of 1 dx, which you can write as integral dx, right? And using the power rule, we'll just add 1 to the exponent and divide by the new exponent. X cubed divided by 3 plus c, right? And now we can do the second one. Since it's 1 times x to the power of 0, right? Since x to the power of 0 is 1, you end up with x to the power of 1 divided by 1, which will just give us x plus c. Now we can condense those two constants at the end, right, and make it into one constant, since if we had done the integral directly from the beginning, we would have just gone a single constant, and we'll end up with x cubed over 3 plus x plus c. Here's another one. Find the indefinite integral of the following. Y is equal to cosine of x. Now, I didn't tell you guys any formulas for how to solve trigonometric integrals. However, remember your trigonometric derivatives, and this should be fairly simple to do. So we know that the derivative of sine of x is equal to cosine of x. So just some substitution, we get integral of cosine of x dx is equal to d dx of sine x, right? Which will give us sine x plus the constant c at the end. Thanks for watching this short video from EDD Academy. Be on the lookout for our future videos. I hope to see you guys soon. Bye.